doing the for chain rule, trees are helpful. So let's start with this chain rule. I see z, problem 1, z equal to x squared plus xy to the third. X is equal to u v squared plus w to the third. Y is equal to u plus v e to the power w. What I see is z is a function of x and y. X is a function of u and v and w. And y is a function of u and v and w. I start from very top, so very outer function. So very inner are u, v, and w, then x and y comes, then z comes, right? So I start from very outer z. Z is connected to x and y. And then x and y are connected to u, v, and w. U, v, and w. And then the question is asking to find the partial z with respect to u, partial z with respect to v and w, and so on and so forth. So now, it seems like one of the nicest way of dealing with this is, I know that I have to, if I'm going from z to x, I have to find the partial z with respect to x. So I find that over here. That is 2x plus y to the third. Then I know that I'm supposed to here find the partial of z with respect to y. And I find it right here. And that is 3xy second. And then over here, I know x with respect to u. So I have to find the partial x with respect to u. And these are all partial because x to this level, they're multivariable. So if I'm going from the above to from any level to this level, it is partial. This level, multiple variables. So if I'm going from that level to here, well, it's going to be partial. And so x, this one, partial of x with respect to v, and so on and so forth. But let's do those over here. So x with respect to u is going to be v squared. X with respect to v is going to be 2uv. X with respect to w is going to be v e to the power w. Y with respect to u is going to be v squared. Y with respect to v is going to be 2. Did I make an error in the past? Yes. Y with respect to u is 1. Y with respect to v is e to the power w. Y with respect to w is v e to the power w. I can put those right here. So it's v squared. This one is 2uv. And that one is v e to the power w. This is 1 e to the power w, v e to the power w. Now, partial with respect to x of, with respect to u of z are these two branches. So partial with respect to z, with respect to u of z is equal to 2x plus y to the third.
Gila, one of your partials, x with respect to you, looks like you went on.
Mark, I can't hear you. Can you type it?
Okay.
Did you guys hear? No, Mark, can you type it? Wrong partial for x with respect to w. Let's go back. X with respect to w. Oh yeah, I mixed up these two, didn't I? Thank you. W to power 3, so this one's wrong. So it's 3W to power 2. And then, so here, okay, so, and then plus, thank you, Mark, times 1. Now, all that good, I'm supposed to have things in terms of u. This is not in terms of u. So what you want to do, if it was just finding the partial of z respect to u at x and y, you will go back and you plug in. So you would plug in for x, you would plug in uv squared plus w to the third. For y, you would plug in u plus v e to the power w here also. Right? So that would give you z with respect to u. But this is asking for more. It's asking to find that at 0.2, 1, and 0. Am I right? Yes. So you can, this is getting messy. If there is a point given, it makes it a lot easier if you find x, y for that point. So let's find x and y for that point. X is equal to, plug it into the, or to that formula. And that would be 2 times 1 to power 2 plus 0 to power 3. That is 2. Y would be u plus v, u plus 1 times e to the power 0. That is 3. So x and y are going to be 2 and 3 in this case. So this gives you x and y are 2 and 3. And then I found the partial. Can everybody see what I'm writing? And then I replace, for x, I replace 2. For y, I replace 3. For v, I replace, what is v? V is 1. For x and y, again 2 and 3. And then I find the value, so 2 times 2. So that's why you see a lot of times we do partials with a table, because it makes your life a lot easier. Plus 3 to power 3 times, v is 1, plus 2 times 2 times 3 to power 2. And 4 plus 27 plus 4 times 9, 36. That is beyond me. 4 times 27, you guys compute. Because I'm sure at this point I'm going to make an error on that. You know, arithmetic is not my strongest suit. There we go. And so that was just partial of z respect to u. The same way you find partial of z respect to v, the same way you find partial of z respect to w. And the process is the same. This is one of the reasons when you're doing this on the exam, I would probably just ask for one of the partials rather than all 3 of them, because it takes time and you have a limited time on your exam. But practice on multiple things so you become comfortable. This is interesting, and these are interesting. Should I just do all 3 of them or just do the optimization? How tired are you? Can you stay with me for another 20 good minutes? Let's do all three of them. So now, we're finding these, but there's no function. What is there instead? Instead, you have an implicit function. So you're computing these two for that, but it's an implicit function, implicit. I don't have z equal to whatever function of x and y. I have x and y and z in an equation together. So I say remembering the implicit differentiation is always a good thing. Partial of z with respect to x is equal to f x goes on top, z comes in the bottom, and a negative sign. And partial of z with respect to y becomes y goes on top. But what is f? F is if you take all the variables on one side and set it equal to a constant. In this case, constant would be 0. So what is f? F of x and y and z is equal to, let's take all the constant on one side, all the variables on one side. So the formulas are, and it's, I guess, easy enough. You know that kind of cross each other. When you say partial with respect to x, f sub x comes up, f sub z goes down. And then you use this. The formula comes in handy. You can implicitly take the derivative by imagining when you're doing with respect to x, y is constant, and do implicit differentiation like cap 1, or you can use the formula. Formula is much easier, I think. You guys not think? So here, I am going to find f sub x. F sub x, y and z are going to be constant. Derivative of x is just x. Here, minus cosine. Cosine derivative of the outside function is sine. Then derivative of inside function is going to be 1. Now, f sub z of x and y and z, this time x and y are constant. Z is the variable. And then derivative of cosine again is sine. Derivative of inside is 1. Now, implicit differentiation, was there a point? Or it was, sorry about that. No, there wasn't any point. So if I'm computing partial of z with respect to x, it would be negative yz plus sine of x plus y plus z divided by xy plus sine of x plus y is z. Z, x. I did it correctly. And similarly with the partial, I'm not doing the second part. Second part, you guys look up the done in the solution. Yes, yes. So let me see. Zoom, I have not been paying any attention. Yes, either way that you do, let me see. Ethan, if you had done it the way that you said, you would get two negative sign for one for the numerator, one for the denominator, and the negative sign would cancel each other out. Okay, so what else is in Zoom I didn't pay attention? Ethan, I don't know. I already left that one. Sorry, I'll go back and I'll take a look at the end. So now let's do optimization. You guys are ready? I think we went over pretty much everything. It was not too bad. And so optimization problem, let's do just one of the 3A. How about that? So 3A is find the critical points and classify them. When I say critical point and classify them as local with a second derivative test,